Welcome back to MLT 115. In today's lecture, we're going to cover statistics and quality control. In statistics, we're going to cover the concepts of things like mean, median, and mode. In quality control, we're going to talk about the difference between trends and shifts, and we're going to learn about Levy-Jennings charts and how they're used in the laboratory. Also, we're going to talk about Westgard rules. This lecture will probably have multiple parts. So we're going to first start talking about statistics. Statistics is the science of collection and the interpretation of data. So why is it important to the lab and in the laboratory setting? Data or a set of data can be analyzed to test the confidence or the likelihood that the results can be predicted based on previous observations. And in the laboratory, statistics are used to assess accuracy of results and to determine the predictive value of results. So basically what that's saying is it helps us assess if our results are reliable or not. We want to make sure our results are the best they can be because our results have a great impact on patient care and treatment. The doctors rely on our results to make the correct diagnosis and come up with the correct treatment plan for the patient. Test results are observations. That is, they are detectable or recognizable characteristics of that sample, of that patient sample. So test results are observations. And we have some different types of observations, and we've talked about these a little bit in the past. And we have two different types of observations that we've talked about. We've talked about qualitative and we've talked about quantitative. Qualitative is when you have a result that's not associated with a numerical number. It's usually a color change, a texture change, a change that's either positive or negative, or a yes, the substance there, no, the substance is not there. As far as your result, there's not a number associated with the result. Your quantitative is a result where you actually have a number. You have a quantity associated with a substance in your sample. It's countable. And they're measured in some type of unit, maybe milligrams, grams, whatever, microliters. And an example would be how many red blood cells are per microliter of blood. So you would know exactly how much of something is in your sample. So you'd have a numerical value. Here's a couple of more definitions that we need to be aware of and know the difference between. A sample is the patient's fluid or tissue that's being tested in the laboratory. So this is what we're actually testing, is the sample. The data is what's being collected from the test sample, or the information that's being collected from the test sample. And the statistics, when we've already learned the definition of statistics, the statistics are being used to interpret the sample's data. Okay, so the patient sample's data, the information that we're getting from the patient sample. A set of data points for a patient sample can be plotted out on a graph, and that's what we're showing here. And the actual curve that we're looking at is known as a bell curve. So this curve that we're looking at is known as a bell curve. And this is a normal distribution of data points. This is also known as a Gaussian distribution. That's just another name for a bell curve. So let's look at the y-axis, and let's actually put some numbers on this graph, or data points, so you could actually see an example of what might be plotted out on a bell curve like this. So on the y-axis, it just says number of data points, but this might be number of people tested or number of patients tested. And along the bottom, or the x-axis, we may be looking at their protein values. So let's actually put some numbers. So let's put some tick marks. And this is number of patients. So this might be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and let's put a few more. 11, 12, 13, 14 patients looked at. And then for their protein values, let's put in 20, 40, and then 60, 80, and 100, 120, and then 140 way out here. And again, these numbers I'm just putting in to illustrate what a graph like this could be used for, and where you could see a distribution of points of actual patient samples. So basically this is showing you a summary of what the curve depicts and the central tendency. So most patients will fall around the 80, and let's say this is grams per liter. So basically what this graph is showing us is that most patients, or the greatest number of patients, are going to fall right around that 80 grams per liter mark for their protein value. So most patients are going to be 80 grams per liter for their protein value. So that very central value in a normal distribution or a bell curve is known as the average, but it also can be referred to as the mean value. In the previous example that we looked at, our mean would have been that 80 grams per liter for the protein value. Most people were right around 80 grams per liter for their protein value, so that would have been the mean in that previous sample. The mean is just one of the values we can assess in the bell curve or distribution when we're assessing data from patient samples. Well, when you have numerical values, we need a way to calculate the mean. So we have an equation for the mean, and this is our equation for finding the mean. Mean equals x with a line over it equals the sum of x with the subscript I over n. So let's go ahead and label what all this means, because this looks more complicated than it actually is. This just represents the mean. The sum times x with a subscript I. This funky looking E just equals sum. It just means sum. And this x with the I just means all the data points added together. And then your N represents total number of values. Again, this looks more complicated than it actually is. The sum would be adding up all your data points. You have a set of data points, and you're adding it all up together, and then divide it by the total number of your values. So if you have a set of data points and you have 5 total data points, then you would be dividing the sum of those data points by 5 if you had a set of 5 data points. So you add up the sum of all the data points and then divide the sum by the number of values. So on the next slide, let's actually do an example of a mean problem using this equation. So here's our example of a mean problem. So it says find the mean of the following numbers. So it gives us this whole set of data points. Okay, so we're going to have to add these data points up or find the sum of these data points, and then we're going to have to divide by the total number of values given, or the total number of data points. So here is our equation. Okay, so remember we're looking for the mean. So we've got a total number of 11 data points. So we're going to be dividing our number by 11. So everything's written out for us down here. Everything's plugged into the equation. So we're taking all our data points and we're adding 20 or 15 plus 20 plus 18 plus 22 plus 27 plus 22 plus 23 plus 27 plus 18 plus 16 plus 22. You add all those together and you get 230. Okay, and we're going to divide it by 11 because we have 11 total points, and that's going to get our average or our mean. So our mean is 20.9. And again, you can use average and mean interchangeably. It means the same thing. So this is our answer. The next concept we need to learn is median. The median is the middle number of a set of data points given. So we have to put our data points in numerical order from the lowest point to the highest point. So we're given the exact same set of data points. We're given the same 11 data points we used in the previous example. And if you put them in numerical order, you're going to have to find the number that's in the very smack middle. And it works out nice in this example because we have an odd number of values. So we're going to have a number that's in the middle. We'll have 5 values that's below and 5 values that's above our median. So our median value is going to be 22, and it's already circled for us here. So the median is the central value. But sometimes in statistics and looking at data, we have to find the median of a set of data points, and we have an even number of data points. So there's not going to be an exact number that falls right in the middle. And for that situation, you're going to have to take the 2 numbers that fall in the center, and you're going to have to get a central value, or you're going to have to find the average of those 2 numbers. So we're given a total of 12 values. Again, you're going to still put them in order, numerical order, from least to greatest in value. So we've got the 15 here, and we've got the 27 over here, so they're in numerical order. But again, we have an even number of data points. So there's not an exact number here in the middle. We have 2 numbers that are in the middle. We have a 20 and a 22. So to find the median, we're going to actually have to find the average of those 2 numbers. So in order to do that, we're going to take the 22, or the 20 and the 22, add it together. you're going to get 42, and 42 divided by 2, you're going to end up with 21. So your median is 21 for this set of data points. The next concept we need to be aware of is mode. Mode is the number that shows up most often in a set of data points. So we're given a set of 16 data points here. So we're looking for the number that shows up most often in this set of data points. So let's highlight some of the data points. So it looks like 15 is showing up pretty often. So let's highlight all the 15s in green. So it looks like we have 4 times that 15 shows up. All right, let's do 10 next. Let's do 10 in yellow. There's a 10, and there's a 10. It looks like 10 shows up twice. Now let's do 20. Looks like 20's on there multiple times. Let's do 20 in, oops, my highlighter don't work. Let's do 20 in purple. There's 20, and there's 20. So we'll have at least 2 20s. And then it looks like we have 8 in there multiple times. So let's do 8 in orange. There's an 8, and there's an 8. So 8 shows up at least twice. And I believe that's all our repeating numbers. So it looks like overall our 15 is the one that shows up the most. So our mode for this set of data points is going to be 15 because it shows up the most. So 15 is our mode. So let's look at another example of mode. We are given another set of data points. Again, we're given a total of 16 values. So let's look for repeating values. It looks like we have 15 that's repeating. So let's go and highlight all of our 15s in green. So there's a 15, there's a 15, 15, 15, and 15. So it looks like we have a total of 5 15s. Now let's look and see if anything else is repeating. Looks like we also have 17 that's repeating, so let's highlight that in purple. So there's a 17, 17, 17, 17, 17. Well, it looks like we have 5 17s as well. Well, in this case, where we have 2 numbers that have the same number of repeats, we're actually going to have 2 modes. Okay. One is not repeating more than the other, so we're going to have 2 modes of 15 and 17. Next, we're going to talk about the concept of range. Range is the total values covered from the smallest to the largest. So to find the range, what we're going to have to do is we're going to have to take the largest value, the largest point given, and subtract it from the smallest value point given to get the range. Okay, and if we're looking at that on a graph, let's say this is number of patients again. number of patients tested along the y-axis, and along the x-axis it could be any test value. And your whole range would be this area here. What your first test value was, and this is your last test value, your largest test value. It could be, let's say 20 grams per liter could be your first test value, and based on the bell curve, only a few patients would test and have a 20 grams per liter. And all the way over on the far high side, it may be 150 grams per liter. That would be the high side of your range. In order to figure out the whole range, you would take the 150 and subtract it from the 20 to get your range. So your range would be 130. So all your test samples that you've tested for your patients should fall within that range, within a range of 130. I hope you've enjoyed the statistics part of this lecture. In part 2, we're going to get more into the quality control portion of the lecture. So I'll see you over in part 2.